This is Unit 1, 1.6, using scale factor, day 1. We are continuing after our quiz that we took, and this will kind of be introducing using scale factor and proportions to find missing side lengths and using those relationships of proportional sides from similar polygons to help us kind of apply that to find missing things. So in the previous section, we were really just setting up those corresponding parts, and now we're going to set up those corresponding parts and use it to help us find missing side lengths. Notice we've split this into 2 days too, so we're going to do something similar to this again on the next day. So to start us off, using scale factor day 1, we're going to look at a ratio of corresponding sides. And when we look at just one of those ratios, this is called the scale factor. So if I had, triangle ABC is similar to triangle DEF, our statement of proportionality, our proportion would be AB, BC, and CA going with DE, EF, and FD. Because these are all equal, what this is saying is that if I just pick one of these ratios, so say I pick this one, if I know both of those parts, then this is called the scale factor. It doesn't matter which one I would pick, this would also be the scale factor. But as long as I pick one of them that I know the two sides for, that's the scale factor, because each one of these things is equal, so it doesn't matter which one I pick. If polygons are similar, we also know that their perimeters are also similar or proportional as well. So if I had this figure and it's similar to this figure that's just a little bit smaller, if all their sides are proportional, so are the sums of all their sides going around. So now this is saying if I add up these three pieces and compare it to, so perimeter of ABC, and compare it to the perimeter of DEF, these two will also be the same proportion as everything else that we've done. The order does matter. So if we are labeling one triangle, we have to have those corresponding parts labeled and in relationship in our similarity statement. So we practiced that before. The order matters here as well. Scale factor, order matters as well. So if I said triangle ABC to DEF, I would have it this way. But if I went the other direction and said, okay, I want the scale factor going the other way, all of these would switch orders. So first object is the numerator. So that's kind of how we help ourselves with the order matters here. And so I'll show you what that means. On our first example, this is what it's asking us. What is the scale factor of ABC to DEF? So what I would do is I would pick 8 goes with 12, the same way that 10 goes with 15, and the same way that 14 goes with 21. And again, notice that because this one was first, this is what I put on the numerator. And that's what I mean when the order matters. The scale factor says it doesn't matter which one you pick. Pick one of them. So if I wanted scale factor, I can pick one pair, and that would be the scale factor of this object. If I simplify this down, I can take a 5 out or use my calculator. 10 divided by 15, and I get the 2/3. So for every 2 of this one, there's 3 of this one, meaning this one's larger, 2 to 3. It doesn't have to have all of these written out. I just wanted you to see that relationship from what we've done before with all the sides. If I only knew 2 of the sides, it would be okay as long as they're corresponding to get that simplified scale factor. On number 2, it says, now what is the scale factor going DEF to ABC? This is going to go the other direction. So before we said, okay, now we're going one direction. Now we'd be going the other way. So we'd have 12 with 8, 15 with 10, and 21 with 14. Now because this is first, we put those measurements on the top numerator part here. Pick any one of these to be the scale factor. 21 out of 14, which simplifies to 3 over 2. Notice that because I switched the numerator and denominator, that's what's happening here as well. The third piece, what is the ratio of the perimeters DEF to ABC? This is what's bringing this into play here. If we know that the polygons are similar, then the perimeters are also proportional in the same way. So because we're going DEF to ABC, these will be the same because they're the same order. So without any calculations, I can say this is 3 to 2. And if you ask me to prove it or show why, it's the idea that if I took the perimeter of DEF, so what is 12 plus 15 plus 21? Let me use my calculator and add those together. 12 plus 15 plus 21. And I get 48. And if I compare it to ABC, which is 8 plus 10 plus 14, which is 32, and I simplify that, so 48 fraction key over 32, it simplifies to that 3 over 2. That's why they're the same. This is in the same order, so if this 12 is proportional to 8 and 15 is proportional to 10, and so on to all the sides, the perimeters will also be as well. And that's why this works every time. Okay, so if I were to do this without kind of talking about it, I would really only need this work. I don't have to show all the factors or all the ratios to find scale factor. You just have to pick one set. So kind of keep that in mind as we go forward. It says, if we know that PQRS is similar to XTZY, so that these two objects are the same, are similar to each other, then what do we know about angles? Angles are going to be congruent. So this means they're the same. Okay, so if I want to know angle P, I don't have it in my picture, but I know that angle P matches up to angle X. So if I know angle X, I know angle P. So this will be 70 degrees. And so on. If I don't know angle R, but I know angle Z, then I know them. They have to be congruent. Angle T has to be 80 because it matches up to Q. And it's nice that these haven't been rotated or reflected or anything like that. So I can find each one of these measures. On 2, now this is asking for the scale factor of PQRS compared to XTZY. So I'm going to pick 2 sides, one from PQRS, and notice that I only know one of them, and relate it to its corresponding side. So the scale factor is 3 to 4. So 3 of these and 4 of those. Find the ratio of the perimeter of PQRS to the perimeter of XTZY. Okay, this is going to be, again, the same order, so I don't have to change this at all. I know that those perimeters are going to be proportional in the same way as the sides. As long as that order has stayed the same, so will this. So even though I don't know these other 3 sides, I know the ratio will be the same. And now on 4, 5, and 6, this is where we actually can use our scale factor to find these missing pieces. So if I wanted to find PQ, this is a side. Sides are proportional. So we want to remember angles are congruent, but sides are proportional. So we want to set up a proportion to solve for PQ. So X is going to go with 9, the same way that 3 went with 4. And notice that because I don't know one of these, I can stop and I can cross multiply. Okay, so if I put an x here, a y here, and a w here for my unknowns, x goes with 9, y goes with 6, and w goes with 7. All the same way that 3 goes with 4. That's my scale factor. So now I'm just using 2 of these pieces with one unknown to find that missing value. So if I cross multiply, I get 4x equals 27. And do 27 divided by 3. Divided by 4. And I get 6.75. It hasn't told me to round or anything, so I'm just going to go to the nearest hundredth. On find P to S, okay, that's my y. So y goes with 6. The same way 3 goes with 4. So I'm going to use that 3/4 again because they all have to be the same 3 to 4. Cross multiply, I get 4y equals 18, and I'm going to divide 18 by 4. And I get 4.5. And the last one, S to R, which I've put W. So this is where W, again, goes with 7, the same way that 3 goes with 4. So because all of these are equal, I'm just using that 3/4 over and over again because it's a scale factor. So again, I get 4W equals 21, and I think we're going to get another decimal here of 5.25. So this is what we practiced before, where we just said, okay, this is how they go together. But if I have unknowns, I can use one of the scale factors, 2 that I do know, to help me find the missing ones. All right, let's look at this next one. Similar idea, we have 2 similar objects. BARK is similar to THEM. And the first goal here is to find missing angles. R goes with E. So if I know E, I know R. So that has to be 85 degrees. On angle M, if I know M, I know K. So there's been a reflection happening. It might at first look like that A would go with M, but we want to make sure that we're still lining up based on the similarity statement because it looks like there's been a reflection that's happened here. So this is 97 degrees. A goes with H, so we have 103. And lastly, T goes with B. There's 75 degrees. The scale factor from bark to them. So bark's going to be our first one. So I need one side of it on top. So I could do this unknown with 4. I could go 10 with 5, 12 with this. So really the only ones that I know that go together are 10 with 5. So I'm going to compare 10 to 5 and even simplify that down 2 to 1. So I didn't know RA goes with 4, but I don't know what this one is. So I'm going to put a variable there. AB goes with HT, but again, I don't know a variable, so I'm going to put one there. And 12 goes with this one, but a third unknown side. So the only one where I knew both of them were 10 goes with the 5, the same way it's 2 to 1. 2 of these, 1 of these. Find the ratio of the perimeters from bark to them. All right, so again, these are the same, so they will behave the same. If the scale factor is 2 to 1, so is the ratio of the perimeters. 4, 5, and 6 are asking about sides, which are proportional. So I'm going to use parts of our 10 goes with 5 is the same way that X goes with 4, is the same way that Y goes with 6, is the same way that 12 goes with W. And I'm going to use this statement, and I'm just going to pick that 10 and 5 to find R to A, which is the X with 4. So 10 over 5, and this is where the scale factor, I'm going to use it 3 times. To cross multiply, 5x equals 40, divide by 5, and this is 8. All right, so think about 2 to 1 ratio. I think this is easier to see than a 3/4 or a 4 to 3, where this is divide by 2. 8 divided by 2, still 4. We've kept that proportional. B to A, now we're going to use, here's Y. So I'm going to use that 10 to 5 and the Y to 6. So because these have to be proportional, these ratios are the same. 5y equals 60. If I cross multiply, divide by 60, and I get 12. 12 divided by 6 still checks out. T to M, I'm going to use 10 to 5 again, and T to M is my W here. But notice that I have to stay consistent. 10 to 5, left to right, 12 to W here. So now I get 10W equals 60. Divide both sides, and I get 6. Half of 12, 6. So on each of these, I'm going back and using this one as kind of like, I know this is true for all of them. So I'm going to just set up my 3 proportions to find the missing pieces. Okay, and the last 2 examples, again, using proportions to find the missing or indicated side blanks. So it says, if the figures below have a scale factor of 2 to 3, find the value of x. So we know that these already have a ratio of 2 to 3. We just need to know how are they set up to compare these. This is why they gave us a picture. This is the smaller one, this is the larger one. So if this is 2 compared to 3, we know we'd have 42 compared to x. So we can find this value, this length here, by cross multiplying. We get 2x equals, I'm going to check what 42 times 3 is, and I get 126. And if I divide both sides by 2, I get 63 here. So the length here, this has to be 63. If I check 42 going with 63, should simplify here to the same 2 to 3 that they gave us. So I'm going to check 42 fraction button, 63, and it does check out to that 2/3. So they gave us a scale factor, and instead of the picture like we used here, where they gave us a scale factor in the picture, now they gave it to us in the sentence. So in our last example here, it says if the figures below are similar with a scale factor of 6 to 5, so again, we want to make sure that we're looking 6 bigger object, 5 smaller object. So if 6 goes with 5, that must be the same way that x goes with 28. Cross multiply to find the value of x. 6 times 28, I get 168. And I'm going to divide that by 5, and it doesn't go evenly because it doesn't end in a 5 or a 0, but I get 33.6. I could check that again. If I check 33.6 fraction button, 28 simplifies to 1.2, and so does 6 divided by 5. So I can check that as well. So the main goal today, we were able to find and apply our scale factor. Angles are congruent, sides are proportional. That is a big key thing about this unit. Angles are congruent, sides are proportional. Let me know if you have any questions as we continue in this unit, and I hope you have a good one.